All right, in this video, we are going to find the slope from a graph. So if we're given a visual, we can easily find the slope of a graph by using what I mentioned in the prior video of our rise over run. I'm going to write that over here, that our slope when we're given a graph can be determined by figuring out our rise over run. Okay, super important here. I suggest you write this for sure on your notes, but then maybe possibly also by your GED formula sheet, just to make the connection between the formula we're going to use in the upcoming video and this method. So if we look at number one here, really what we want to do is find 2 points. And on the examples we're going to go through to start, we're given the points. See how there's a coordinate point there and a coordinate point here? And basically what we want to do with these 2 points is to create a triangle based off our rise and run. So remember I mentioned that our rise, I want you to view our rise as vertical, right? Up and down. So I know we think rise, we think only up, but rise also can go down, okay? So for this first one here, if we look, I'll get fancy with the color here. So if we look at our first point again, if we read left to right, I want to look right here at this point. To get to this point, I have to go up 1. Right? See that unit from here to here, I'm just increasing 1. Okay? And now I want to run over to my other point. So I can run to the right, I would move 2. Right? So if we relay this to numbers, if I have my rise over run, my rise right here is 1 unit and my run is 2. I rose 1 and I ran 2. So the slope of this graph, just by determining it using rise over run, is a half. Okay? And if we think of our benchmark, remember our benchmark of kitty corner like so? I can sketch a line here and I'll just erase it. Remember this, a perfect diagonal has a slope of 1. Well, this line is flatter than that, right? It's under that 1. So our value isn't quite 1, which makes sense that it's less than 1. So that benchmark really helps us determine that. Okay? Let's look at number 2. So again, if I'm reading this graph left to right, I hope we kind of notice right when we look at it, it's going down to the right, right? So if I start at my leftmost point, to get to my other, just up or down, I will go down 2 units and over 2 units, right? So my rise here is a -2, so I'm going down 2, and my run is a +2. It's really helpful to view your rise, again, like I mentioned, as your up and down. And frankly, your run, your run can always be to the right. If you're truly reading a graph left to right, your run will always go to the right, which is helpful. Your rise determines the sign, your run will always be positive to the right. So if we look at this here, we have our rise over run, so we have -2 over 2, and that can simplify to a -1. Right? A -2 divided by 2 gives us a nice integer of a -1. This has a slope of -1. If we look at this next one here, number 3, just looking at it, it's going up to the right. If I read it left to right, it's going up to the right. And I start at my leftmost point, I'm going up 1 over 2. So again, we have a slope of a half, up 1 over 2. If we look at number 4 here, start at my leftmost point, I need to go down and over. So the distance I went down is 1, 2, 3, 4, 5. So my rise is -5. And my run is 1, 2, 3, 4. Okay. This is also the same as if your negative is on the outside, like so. You will see it both ways. As we continue learning about slope, we are going to kind of assign that negative to the top. So just know that they're both equal and that they're both correct in this case. We're going to be strategic about where that lives here in upcoming lessons. And also, maybe when you see this, you think, well, that can be simplified, right? This is an improper fraction. So this could be simplified to -1 1/4. And for the sake of finding the slope of a graph, when we're given a graph, finding the slope when we're given a graph of a line, you want to leave it as improper. You want to leave this as -5/4. And the reason being, it gives us a nice rise over run, right? It helps us out with this concept. If we had -1 1/4, it's just not as pretty. We'll talk about this connection towards the end of this video, but just something really to consider there of leaving it as an improper fraction. We'll talk about what that looks like in IXL also. For number 5 here, we have a horizontal line. So just by recall or just by memory, I want us to remember that that has a slope of 0, right? We could look at it though, there's no rise, right? So my rise is 0 and my run here is 1. So 0 divided by 1 is 0. It's a way to look at it if you really want to mathematically look at the rise and run. All right, number 6, if we look at this line, it's going up to the right. So from this point up, or this point, we want to go up and over 1. So we want to go up 1, 2, 3, 4, and over 1. So we have 4/1. So when to simplify and when not to, I might have contradicted myself here. In this example, we simplified this to -1. It came out to a nice whole number. This one we didn't want to simplify because it wouldn't give us a whole number. It would give us a negative mixed number. So for this one, 4 divided by 1, that does simplify to a whole number. So we want to just simplify that to 4. This would have a slope of 4. And if we looked at our steepness of a 1-to-1, doesn't matter where that line is, remember it's just 1 up, 1 over, 1 up, 1 over. Notice how much steeper this line is. So it makes sense. If this has a slope of 1, anything steeper than that will have a slope that's greater than 1. Right? So just that knowledge alone will help us with multiple choice questions. If we look at number 7, first thing I want your eye to see is it's negative. It's going down to the right. And then you can determine your numbers. My rise over run. So I go down 1, 2, 3, 4. And my run is 2. So -4 divided by 2 is a -2. So this has a slope of -2. Some students often ask me, like, well, why can't we do this? If I delete this here. Is it the same as if we did this? Over and down, right? And it really is if we have a good concept of our rise and run. Our rise is still 4, our run is 2, and it's going down, so it's -2. But I always take care of my rise first, just because that's naturally what my numerator is. So I just think it's good practice to always determine, okay, am I going up or down? Also helps to read the graph correctly, right, left to right. Here I'm going down to get to this point and then over. It just spits out the correct sign of your slope. So the other way works, it's just a little sloppy in my opinion. For number 8, if you see this blue line here, it's a vertical line. So we talked about a slope of a vertical line is undefined. Okay, undefined. And now let's talk about why that is a little more. Okay, let's talk about why that is. So if we look at our rise here, this is rising 2, looks like, or going down 2. That's kind of hard to determine. We'll say rising 2. And our run is 0. We're not going left or right, right? So our rise is 0. So if you did this on a calculator, if you did 2 divided by 0, 2 divided by 0, we get a divide by 0 error. Okay, and when that happens, that's pretty much saying, hey, this slope is undefined. Okay? It means mathematically we can't divide by nothing. It doesn't matter if I had 100 divided by 0, anything divided by 0 will give you a divide by 0 error. And that triggers to the word undefined, okay, undefined in the slope world. Okay, just a little bit further knowledge here. Let's think of, so this is totally off the slope topic, just FYI, But just to talk a little bit more about what this undefined means. What if I had this? Think about the square root of 4 and tell me what that is, right? Square root of 4 is 2. And that's technically just one solution, right? And that's because 2 times 2, whoops, 2 times 2 gives me a positive 4, right? Can you think of another solution to the square root of 4? Would be negative 2 times negative 2. That also yields a positive 4, right? So technically the square root of 4 is 2 or negative 2. Both conditions work, right? What if I had this, the square root of negative 4? Right, let's think about that, the square root of negative 4. So I need to find two factors that are the same that equal negative 4. And there's no situation that does. I either have a 2 times 2 gives me a positive 4, a negative 2 times negative 2 gives me a positive 4. So mathematically, the square root of a negative 4 is undefined. There's no number that has this, there's no two numbers that are the same when multiplied give me negative 4. It's mathematically impossible. And if we look at that on our calculator, if I did the square root of negative 4, let's clear this, make sure. If I did the square root of negative 4, I get a domain error. So anytime really you get an error, you could have made an error, but there's probably a reason for it. If you type that in again, right, you're going to get a domain error, and really this is what it means. It's mathematically not possible, right? So this calculator doesn't say the word defined, it says domain error, but it really means the same thing. Okay? So just a little side conversation there. But overview of this video is we can determine the slope of a line when given a graph by using rise over run. So let's look at what this looks like in IXL. So these graphs look very similar to what we just left, the page we just left, outside of the units on what the couple we worked on before. The number lines just went up by ones. And notice here they're going up by tens. But good news is our x-coordinate, our x-axis, goes up by tens and our y-axis goes up by 10. So you can still use the same strategy of rise over run. What's different here, and possibly on GED test questions, is you don't have 2 points that are like pre-pointed out for you, right? So on what we just left, this kind of gave us these 2 points, so we could just easily connect the two with that triangle. This does not. So you have to find 2 points, at least 2, find any 2 points where you can make that triangle. So if you notice this point right here, this is point 0, 80. And if we look here, this is hard to tell, right? This is point 10, I don't know, is it 83, is it 84? It's not a perfect coordinate, as in it doesn't, on these, see in the background, the light gray, a perfect coordinate crosses at that point. This doesn't. If we keep following the line, this one doesn't either. I mean, this could be point 20, 86, 87, it's hard to tell. But this one we know, right? This is point 30, 90. So you want to follow your line where you can find 2 points that are perfect points. Okay, so right here and right here are my points. So I want to go up 10 over 30, right? And because these intervals are the same, you really could just count the units. Going up 1 over 3. So this has a slope of a third, right? And it's flat, right? This isn't too steep, so it makes sense that we get a fraction out of it, not a whole number, right? That's because it's a flat slope, it's less than 1. I also mentioned that I'll talk about this in the IXL. It says simplify your answer and write it as a proper fraction, which means the numerator is less than the denominator. Improper, where the numerator is bigger than the denominator, or an integer. So this is basically saying don't change it to a mixed number if it ends up being an improper fraction. Let's look at another example here. I always read my graphs again, left to right. So I start right here at that point 040. That looks like a great point. Just follow your line. Here's another one. So right here I see my triangle. I have a rise of 1 and a run of 2. So this has a slope of a half. Okay, let's look here. So first off, it's going down to the right. So maybe you want to automatically put a negative there so you don't lose that. And again, it doesn't matter where you start. My eye just goes to the leftmost point of the line, and I just follow it. So it looks like right here is a good point. You can kind of see the staircase here. Go down 2 over 1, down 2 over 1. So it looks like negative 2 over 1, which really simplifies to a negative 2, right? So you could just enter a negative 2 here. IXL will accept negative 2 over 1 also. So I just wanted to go through what it will look like on IXL, or when you're taking your GED test. You know, you're going to be looking at a screen. Use your mouse to your advantage and really see that triangle, right? So this one goes up, way up here. Right, so here's our triangle. It's going up 3 over 1, 2, 3, 4, 5. So it looks like 3/5. Use your finger or your mouse to guide that. Don't just use your eyes only, okay? All right, go ahead and practice this in IXL. The more you do it, the more natural it will feel.